right, guys, so on Friday we reviewed the two special right triangles, which is 45, 45, 90, and 30, 60, 90. So if you see a 45-degree angle, then you'll know it's the 45, 45, 90 special right. And what you have to remember about 45, 45, 90 is it's x, x, x root 2. The two sides are the same. The hypotenuse is the side length times root 2. So right now I have across from the 45-degree angle is 3. So if this is another 45-degree angle, across from that is going to be 3 too. Because if they're the same angle, then they've got to be the same side length. Okay, so this side right here should be a 3. And then the hypotenuse is the side length times root 2. So the hypotenuse for this one would be 3 root 2. All right, pretty straightforward for the first one. We okay with that? The second one here is a 30, 60, 90, because if I have that this is 60, then this has to be 30. Okay? And this rule is opposite of the 30-degree angle is like your x. That's like your base side length. Your hypotenuse is 2x. So if this 4 is in the hypotenuse spot, I'm going to set it equal to 2x. All right? And that's going to tell me what my small side length is. Because if that's 4, then my small side length, I just divide that by 2. So if I wanted to solve for x here, I could divide those sides by 2. So my small side length, x, is going to be 2. All right, so opposite of the 30-degree angle. My pen isn't really weird today. It's not letting me write the way I like. All right, so the small side length is half of the hypotenuse. And then opposite of the 60-degree angle is the small side length times root 3. So this would be 2 times root 3. I don't understand why this is like this. I have to do everything like delayed. So we get 2 root 3 there. Questions on that one? All right, so the third one is another 30, 60, 90. I know that because I've got a 60-degree angle. So in the 30, 60, 90, your main side length is opposite of the 30. So my little leg is 5. That's the important one. The hypotenuse is double that. So 5 times 2 is going to give me this one. And then my across from my 60-degree side length is my little side length times root 3. So this one's 5 root 3. Pretty straightforward on that one. All right. Number 4 here, my triangle is a 30, 60, 90 because I've got the 30-degree angle there. So opposite of the 60 is my small side length times root 3. You can see if I set that ratio next to each other that there's a 4 in the x spot. So I really don't have to solve for anything. My small side length x is going to be 4. Because if this is small side length times root 3, I've already got the root 3 part. So this is going to be a 4. And then this is 4 times 2, which makes this side length 8. All right, so that one was pretty straightforward. This next one is a 45, 45, 90. I know that because I've got a 45 here. Right, so opposite of the 90-degree angle is my x times root 2. So just like the last one, I already know what the x is going to be. So root 2 is already taken care of. That must mean the small side lengths are 5. And in a 45, 45, 90, the two side lengths are the same. And then the last one is another 45, 45, 90. And I've got one of the legs. So I know the other leg, and then the hypotenuse is the leg times root 2. You just have to work on memorizing the rules. It's as simple as that. Like in a 45, 45, 90, the two legs are the same. The hypotenuse is the leg root 2. In a 30, 60, 90, you've got your short side is like your base. We'll call that your x. Your hypotenuse, you double that x. And your 60-degree angle, you take whatever that x is and multiply it by root 3. All right? Today we're going to do SOHCAHTOA. We're going to review SOHCAHTOA. So in your toolkit, this is on page 4. You've learned SOHCAHTOA before, it's just a matter of remembering what it means. The letters in SOHCAHTOA all stand for something. So as you're getting your toolkit out, I'll remind you that the S stands for sine, which is a trig function, and that trig function means opposite over hypotenuse. I'm just going to add the line for the division that the toolkit doesn't have. All right, the K stands for cosine, which is adjacent over hypotenuse, and the TOA, which is the T, stands for tangent, which is opposite over adjacent. In order for us to be successful in this part of the unit, the calculator has to be in degree mode. So we're all going to have our calculators and we're going to switch them to degree mode quick so we don't make that mistake. If your calculator's in the wrong mode, you will get the wrong answers for every single problem. So I'm going to pull up the calculator app and I'm just going to show you how to get to degree mode. No matter what calculator you have, they all have a button that says mode. So you hit mode and then you'll see my screen's flashing. The fourth line down is radian and degree. In this unit, eventually, we're going to be switching back and forth between those two modes. So sometimes it'll be in degree mode and sometimes it'll be in radian. But for this particular section, we're going to be in degree mode for everything. So I need my darkened part of my calculator to be over degree. So I scroll down and I just hit enter so that the degree is the one that's highlighted. All right. So again, in order to do any of the SOHCAHTOA stuff, you need to be in degree mode in your calculator. So now that I've switched that, when you're solving for an angle here, you're just going to have to remember to use the inverse button. To get the inverse button on your calculator, you'll hit second, and then whatever trig function you're working with. So like second sine, second cosine, or second tangent. So you can jot that down if it helps. So second sine, second cosine, or second tangent is going to get you the inverse of that function. If you're solving for an angle, you need to use the inverse. And I'll show you that in these examples here. All right, so here I've got a right triangle, and in this right triangle, I can't use Pythagorean theorem, because in order to use Pythagorean theorem, I would need 2 of the 3 side lengths, and I only have 1. And I can't use special right rules because I would need a 45-45-90 or 30-60-90, and I have a 20-degree angle, so it's not a special right. So if you can't use Pythagorean theorem and you can't use the special right triangle rules, that's when you go to SOHCAHTOA, all right? So to use SOHCAHTOA, I have to figure out which trig function I'm going to use. So right now, I'm going to base that all off of this 20-degree angle. Compared to that 20-degree angle, I have opposite of the 90-degree angle, so I have the hypotenuse for sure. And then I have to decide, do I have the adjacent or do I have the opposite? Opposite is across from the 20, so this would be the opposite. Adjacent is next to, so this is the adjacent. So the x is the adjacent leg, and I have the hypotenuse leg. So I can't do anything with the opposite leg. There's not even a label there. So I am only working with the A and the H. So I look at my SOHCAHTOA and figure out which of those involve the adjacent and the hypotenuse, and that's the cosine, right? So I'm going to set up the cosine for this one. The cosine of some angle, in trig we call that angle theta. Okay, so the cosine of theta is equal to the adjacent over the hypotenuse. So all I'm going to do is I'm going to filter in what I know. All right, theta is the angle. So if you're given like an angle, you'll take that theta symbol out and you'll put the degrees in there. If you're not, you might be replacing that with an x. But in this case, we have the angle. We have the 20. So I'm going to say cosine of 20, right, because that's the angle, equals the adjacent leg, which we labeled as x, over the hypotenuse leg, which we labeled as 10. The goal in this problem is to get the x alone. You can create from this, which is something called a proportion. You don't even have to put the 1 if you don't want. but to solve a proportion, anytime I have a fraction, I can cross multiply. So to get this x, I can cross multiply, so it would be like 1 times x is equal to 10 times the cosine of 20. You normally, when you write this out, you put the number in front and the trig function at the end. So when I write this, it would be 10 cos of 20. You just want to make sure that before you type this in your calculator, you are in degree mode, because if you are in radian mode, which most of your calculators will filter to automatically, you won't get the right answer, all right? Because the cosine of 20 radians is different than the cosine of 20 degrees, so you just have to make sure you're in the degree mode. And then from here, I just type that in my calculator. So 10 cos of 20. I can type that right in the home screen. As long as I'm in degree mode, I'll get the right answer. We're going to round to 2, well, no, I would say 2 decimal places, but I can't here because the 6 is going to bump this up. So we'll call this 9.4, and it's a side length, so I'm not going to put a degree on that, right? If I was solving for an angle, I would. So this is 9.4. All right, let's look at the next one. We've got an angle again. We've got the 53. I don't have the hypotenuse. This would be the hypotenuse. It's opposite of the 90 degree. So I don't have that. Opposite of the 53 is 20, so that's called the opposite side length. And next to the 53 is the x, so that's called the adjacent side length. So I want to work with the trig function that has the ratio that has an adjacent and an opposite in it. And that's the TOA. Tangent is the one that doesn't involve the hypotenuse. So I'm going to set this up for a tangent. And tangent of any angle is equal to opposite over adjacent. That's the general. I'm going to filter in what I know. I know that the angle is 53, so that's my theta. My opposite side length was 20, and my adjacent side length is x. Now I'm going to do cross multiplication. You can put a 1 here, but you don't have to. This x multiplies up, and I get x tangent of 53 is equal to 20 times 1. Which is just 20. And the goal here is to get x alone. And this is like x times the tangent of 53. So to get rid of this, I can divide the tangent out. So my answer is going to be 20 divided by the tangent of 53. That's what I'm typing into my calculator. As long as I'm in degree mode, the calculator will automatically read that as 53 degrees rather than 53 radians, which is different. So 15.07 if we're rounding to 2 decimal places, and that's a side length, so I don't need to label it degrees. So I get 15.07 for that one. And then for the third one, I'm going to be working with this angle here, which is x. I don't know what it is, okay? But opposite of it is 26. And opposite of the 90-degree angle is the hypotenuse. So I want to be working with the trig function that uses the opposite and the hypotenuse, which is the sine. So sine of an angle is equal to opposite over hypotenuse. In this case, I don't know what the angle is, so I'm going to call it sine of x is equal to the opposite side length over the hypotenuse. You can't divide out sine, right? Like when you hit the sine button on your calculator, there's automatically a parenthesis. So you can't do like 26 divided by 32 divided by sine. when you're solving for an angle, you have to use the inverse button. Okay, so to get rid of the x, we're going to do the inverse. So we'll do the sine inverse of 26 over 32. To get the sine inverse button, you hit second sine. So the opposite of sine, to get rid of sine, is the sine inverse. That's a button on the calculator. So when I hit that, 26 over 32. So I'll hit second and then sine, and you'll get that little -1. That means we're solving for an angle. And then I'll do, was it 26 and 32? Right. Because I'm solving for an angle now, the label on this will be degrees. So I'll call it 54.34 degrees. So the difference here is, for the first two examples, I was solving for a side length. So I was just using the regular cosine, the regular tangent. If you solve for an angle, you need to use the inverse button on the calculator, and that will get you an angle. All right, so I'm going to leave those up there while you try 4, 5, and 6. When you're trying number 4, you should be using the inverse button. And when you're trying number 6, you should be using the inverse button, because for both of them, you're solving for an angle. Number 5, though, you don't need to use the inverse button because you're solving for a side length. Does that make sense? All right, so you try those 3 examples there. What's up? All right, so for the number 4, I used cosine. I had the hypotenuse because I had the side length opposite of the 90-degree angle. And the 9 is touching the x, which makes it adjacent, not opposite. So I've got the adjacent and the hypotenuse, which leads me to do cosine. Cosine of my angle, which I don't know, so I put x, is adjacent next to 9 over hypotenuse 10. And then if I want to solve for the angle to get rid of the cosine, I need to use the cosine inverse. So I ultimately did the cosine inverse of 9 divided by 10. 25.84 degrees. You okay with that one? All right, next one, I have 75. I have the hypotenuse leg, or at least I want to know the hypotenuse leg. So I'm either going to use sine or cosine. And then the 17 is opposite of the 75. It's not next to it. So I used sine. So I did sine of the angle, which is 75, is equal to the opposite side length, 17, over the hypotenuse side length, x. Then I cross multiplied that, but x still wasn't alone. Right? So when I cross multiply that, I do the x times the sine 75, and then 17 times 1. But the sine, or the x still isn't alone. I have to divide the sine out. So what I was typing in my calculator was 17 divided by the sine of 75. And I got 17.6. We okay with that one? All right, and then the last one, I don't have the hypotenuse leg, so it's got to be tangent. So I used tangent. Tangent of my angle, which is x, is opposite, which is 72, over adjacent, which is 10. And then to get rid of the tangent, I had to do the tangent inverse. So that led me to 82.09. What do we think? Okay with that? All right. So second half of class, we're going to do reciprocal trig, which is just 3 more trig functions. So in your toolkit, this is on page 4. So if we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are 3 other trig functions. They are called the cosecant, the secant, and the cotangent. Knowing which one they go with is confusing, because when I see cosecant, the root of that is cos, but it actually doesn't go with cosine. it goes with sine, okay? Secant, even though it starts with an S, it actually goes with cosine. Tangent's easy though, cotangent goes with tangent. But these two are opposite of what they look like. Now here's the thing, on your quizzes and tests, they will be listed out like this. And they will always be listed out in the same order. And they will always be listed out next to the one they go with. Sine goes with cosecant. Cosine goes with secant. Tangent goes with cotangent. So you really don't have to memorize which one they go with, okay? If they are next to each other on your problem blanks, they are the pair. Does that make sense? Because otherwise you have to memorize it and it's confusing because it doesn't go with the pair that makes the most sense. Because math never tends to do that, all right? So here's what we're going to do for a problem like this. So it says let theta be an acute angle such that tangent theta equals 4/3. So theta is an angle. What I know about it is it's acute. So what does that mean? It's got to be less than 90. So eventually, the ultimate goal is to figure out what the angle is. If you get to this blank and you get an angle that's more than 90, then you did something wrong because the directions are saying it's got to be an acute angle. I want this angle to be somewhere between 0 and 90. So that's a piece of information. And then I know that its tangent is 4/3. So here's what I'm going to do. I'm going to draw a right triangle out because using tangent implies that it's a right triangle. Tangent only works with right triangles. So I'm going to draw a right triangle out. It doesn't matter which way your right triangle looks, right? If you want to draw your 90-degree angle somewhere else, you totally can, all right? So the fact that it has a tangent means that I'm working with a right angle, and I'm going to pick one of the two remaining angles to be my theta. It doesn't matter which one you pick. They're both acute in picture, okay? So I'm going to pick this one to be theta. That one could be theta too. It doesn't matter. Okay, you're just drawing a picture. Everybody with me so far? Got to make it a right triangle because it's tangent. Got to pick one of the angles to be theta so I have something to solve for. Now here's the piece of information I know. I know that the tangent is 4/3. Well, tangent is the TOA of SOHCAHTOA, meaning that I have the opposite and the adjacent leg if I have the tangent, right? So if I were to fill out and label my triangle here, the opposite of my theta is going to be 4 and the adjacent of my theta is going to be 3 because that's the information I know. So if this is the angle I chose to be theta, the opposite side of it is the side that it's not touching. So that's 4. And the adjacent is the side it is touching. That's 3. I don't know the hypotenuse because tangent doesn't have a hypotenuse in it. Are you with me so far? Keeping in mind that your picture does not have to look identical to mine, you could flip your right triangle. You could pick the other angle to be theta, but you just have to be consistent with wherever you decide to pick theta, your opposite's 4, your adjacent's 3. Okay, you with me so far? All right, so anybody have any ideas how I could figure out what that is? Pythagorean theorem. So we can find the third leg of the triangle using Pythagorean theorem. I have 2 of the 3 legs. So to find this leg, I'm just going to call it x for now. If I want to find x, I'm going to use the Pythagorean theorem. So I'm going to do 3 squared plus 4 squared equals x squared. Just using Pythagorean theorem. We've got 9 plus 16 equals x squared. And then we've got 25 equals x squared. So if you use Pythagorean theorem, you work your way through this picture, you get the third leg of the triangle. You okay so far? Okay, so here's what I know. I know that tangent theta is 4/3. That's given to me, so I'm just filling it in the blank. I just took it from the question and wrote it in the answer. I didn't do any work. We okay so far? All right, well, sine is opposite over hypotenuse, now I have all three legs, I know what sine is. Sine is the opposite leg over the hypotenuse leg. So sine is 4 over 5. Cosine is the adjacent leg over the hypotenuse leg. Well, I knew the adjacent leg was 3, but now I know the hypotenuse is 5. So I've got all three of those ratios. The reciprocal ratios are next to the ones they go with. And a reciprocal is just a really fancy word for a flipped fraction. If you're finding the reciprocal of something, you just take the numerator and make it the denominator and vice versa. So if I want to find the cosecant of theta, cosecant is just taking this fraction and flipping it. These are a pair, they go together. So the cosecant of theta is 5 over 4. Cosecant is hypotenuse over opposite. You're just flipping the fraction. Cosine is the reciprocal of secant. So if I want to find the reciprocal of that, I'm just going to take the existing fraction and flip it. And then finally, tangent's reciprocal is cotangent. And if I want to find the reciprocal, I just flip it. So you can find all 6 trig functions as long as you know 2 of the side legs. We okay so far? Now the ultimate goal in this problem was to figure out what the angle was. There are 3 different ways that you can find this angle. You could do the sine inverse of 4/5. You could do the cosine inverse of 3/5. Or you could do the tan inverse of 4/3. It does not matter which one you do. All 3 of them are going to give you the exact same angle. My recommendation is to use the one that's given to you in the problem, because what if you solved for Pythagorean theorem wrong and that 5 is wrong? Now your answer is going to be wrong. Does that make sense? Whereas I know that the tangent of 4/3 is completely accurate, it's given to me in the problem. So I'm going to use that one. However, you'll see when you use the other ones, you get the same answer. All right, so I'm going to do the tangent inverse of 4/3. You just have to make sure that your calculator is in degree mode. So it's second tan of 4 divided by 3. So 53.13. I wanted it to be acute. I wanted it to be less than 90 degrees. All right, you can't do the inverse of any of these because there's not a button for them on your calculator. So you've got to, when you're solving, stick with these. This is new vocab though, but they're called the reciprocals. You're just flipping the fractions. All right, let's just do one more example like that. It's not as easy because this third side length is not a perfect square. All right, so here's what we're given. We're given that theta, which is an acute angle, meaning that my final answer needs to be somewhere between 0 and 90, has a sine of 5/6. Okay, so if I'm looking at a right triangle, and I'm just going to keep the right triangle looking the same for consistency purposes, but it doesn't have to look like that, all right? So if that's my right triangle, I know that the sine is 5/6, meaning I know the opposite side is 5, and the hypotenuse is 6, because sine is opposite over hypotenuse. Before I was given tangent, so I was given different information. So the opposite side is 5, and the hypotenuse side is 6. We can again use Pythagorean theorem to solve for the missing side length. We'll call it x for now. All right, so 6 squared equals 5 squared plus x squared. 36 equals 25 plus x squared. Because I have the hypotenuse, I have to put that on the other side of the equation for this one. So if I subtract, I get so it looks like the square root of 11 is going to be my remaining side length. I got the third side length using Pythagorean theorem. Now I'm going to fill in what I know. I know that the sine of theta is 5/6, which means its reciprocal function, which is called the cosecant, is 6/5, because a reciprocal is just a flipped fraction. I have them paired next to each other so you don't have to memorize what goes with what. All right, cosine is adjacent over hypotenuse. So if this is my angle here, the adjacent side length is root 11. And the hypotenuse is 6. So if I want to take the reciprocal of that, if I flip it, what happens is I end up with a root on the bottom. So now we got to go back to what we did last week, and we have to rationalize that by getting the root out of the bottom. So I'll multiply by root 11, and I'll get 6 root 11 over the square root of 121, which is just 11. The tangent is the opposite side length, which is 5, divided by the adjacent side length, which is root 11. But there's a root in the bottom, so I'm going to rationalize that. Root 11 times root 11 is root 121, which is just 11. Now, if I want to take the reciprocal of that, use common sense, okay? You're going to flip the fraction, right? Don't flip this fraction. If I flip that fraction, a root's going to end up in the bottom. If I flip the original fraction, the root just goes in the top and you don't have to rationalize. So instead of flipping this one, I'm going to flip the original and say that the cotangent is root 11 over 5. You could flip this and you just have to re-rationalize, and you're going to end up back here anyway, flipping that. So just save yourself the work and flip the original rather than the simplified. All right, and then finally we want to find theta. Now, to find theta, I could use sine, cosine, or tangent, but look at them. The cosine and the tangent both have square roots in them, which makes them a little more complicated. So I am going to use the sine. It's much easier to type in 5/6 than root 11 over 6 or over 5 than 5 root 11 over 11. So I'm going to go with the most simplest form of the existing 3. 5/6 looks the easiest. So I'll do the sine inverse of 5/6. And I'll take that decimal, so 56.44. This problem right here has every single thing that we've done in this unit so far except for special right triangles. So it's got roots and rationalizing denominators. It's got Pythagorean theorem. It's got SOHCAHTOA and solving for SOHCAHTOA. Okay, so it's got everything in it, and now it's got this new thing called reciprocal functions. We okay with that? All right, so at this point, if you're keeping up to date with the Delta math, you can do the first 8 skills. Because remember, they're not numbered. So you can do simplifying radicals, multiplying and dividing a radical expression, Pythagorean theorem, special rights, and then all of this is SOHCAHTOA. Using trig to find a side, using trig to find an angle, identify trig ratios, find trig ratios. All of that is the stuff from today. This is going to be due on Thursday night. Okay, so you should have time in class. You've got 10 minutes now. You should have time in class tomorrow and time in class on Thursday to work on that too.
How many questions is it?
I think it's 10.
And then for the test tomorrow, we're allowed
Thursday. We got plenty to do the test tomorrow.
No, the people that's making.
Oh, right. Exactly.
That's what I
Right, yeah. Okay, so what is that tomorrow?
Okay, for the test tomorrow. Oh, do we have class time too?
Yes, so I'll give you bonus block and then you can eat it at class time, however much. Thank you for reminding me. All right, seniors, remember, you have a test to make up, bonus block. I sent you the review guide, I sent you the key. You can work on that. So what you'll do is you'll work on it during bonus block and then you'll take however much class time you need to finish it. And then you'll just catch up on whatever notes you miss after that. All right?
Wait, when are we doing that?
Tomorrow, bonus block, you're all mapped in. And then you can just go into class however much time you need.